Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So in this problem, we need to explain why transition metal elements can have multiple oxidation state, whereas the main group elements can have only a single oxidation state. So from the definition of oxidation state, we know that the oxidation state is the number of charge on a single atom or ion. So for example, if you write Cl minus, that means that this chlorine atom has one negative charge on it. And if we like write magnesium 2 plus, that means this magnesium ion has two positive charges on it. And these charges means that how many electrons they have received or donated in their or from their outermost shell or valence shell. So in case of this magnesium, it has donated two electrons to get this plus two oxidation state, and this chlorine has received one electron in its outermost shell to become Cl minus. So these main group elements, they have a very specific number of electrons in their outermost shell, which they can and that's why they actually can have only a single oxidation number. Like this Mg2 plus, if you just want to make it Mg3 plus by removing one more electron from its electronic shell, it will take a very high amount of energy, and that's why we cannot make an Mg3 plus ion. Similarly, in case of chlorine, if you would like to give this chlorine one more electron and you would like to make it Cl2 minus, this will take a huge amount of energy, and that's why it's not possible in general. But uh, 3D, in case of the transition metal elements, um, they have unpaired electrons in their d orbitals, or we can say that degenerate d orbitals. That means that they have unpaired electrons of similar energies which they can easily get rid of to have multiple oxidation state. We are considering manganese as an example here, which has 25 electrons, and manganese uh, have an electron configuration of this same electron configuration up to argon, and then it has 3d5 and 4s2. So if we write this electron in the box form, this is our 4s2 box, and here is our 3D box, and we know that we have five degenerate d orbitals, and 4s has only one orbital where two electrons lie in opposite spin, and in the d orbitals, manganese has five unpaired electron. So when it is forming a compound, it can either get rid of this two 4s electron to become Mn2 plus, or it can get rid of any of these or all of these uh, d electrons to become Mn3 plus by just getting rid of two 4s and one 3d, or can become Mn4 plus by getting rid of these two 4s and two of the 3d, and all the way up to Mn7 plus by getting rid of or donating all these seven electrons. And that's why the transition metal elements can have multiple oxidation state, because they have uh, degenerate d orbitals where they have multiple one or more um, unpaired electrons which they can donate easily and can have a multiple oxidation state.